Hello and welcome to Ramble. It's been a while since I've posted. My bad. Also not such a great day for me, but hoping doing this can pick up my spirits. But yeah, for the first video or two or three, you're just gonna need to deal with glams also. Right, we are looking at paper 2, November 2023 from the department. Question 5.2, given cos to the 4x plus sine squared x times cos squared x over 1 plus sine x. The first question asks us to prove that that expression is pretty much the same as 1 minus sine x. Okay, so let's see. What immediately stands out for me up here is that there is a common factor of cos squared x in our two terms. So we can factor that out and see where that takes us. Another interesting thing is that we have a 1 plus sine x over here, but on the right we have a 1 minus sine x. So that makes me wonder if we're going to need to multiply top and bottom with the conjugate, which is 1 minus sine x, which would create a difference of 2 squares down here, and then yeah, we could see where that takes us. Anyway, so those are just some preliminary thoughts. So in our identity for 5.2.1, just going to start by rewriting it. Yeah, you can tell I'm out of practice. Okay, I don't know if you can tell, but I can tell. I'm very shoddy writing here. Or maybe it's the writing of demoralization. Right, so I'm factoring out my cos squared x and seeing what that might do for me. Okay, so I see here that in my brackets I'm left with a 1, right? Because we know that this is always going to add up to 1. So I can replace it with 1. And yeah, okay, so this is where multiplying with the conjugate is going to come in handy. Because if I times the top and the bottom by 1 minus sine x, so this is going to become 1 minus sine squared x, which is the same as cos squared x, and those are going to cancel out. So shout out to my hunches, shout out hunch. This is too thin for my liking. Let's try that again. Okay, I think also just in general the red maybe doesn't work on the dark mode situation. Okay, right, so that becomes cos squared x times, I'm just going to hold back on multiplying out because, again, well, we already know where it's going to go, but even if I didn't know where it was going to go, my hunch would be that we are ending up with a 1 minus sine x. So, you know, it's probably going to be this one. So if I multiply out, I'm probably going to have to factor out again to get this back. So rather just hold back on multiplying out until it is clear where things, well, not where things are going, but if you're going to need to cancel. I don't know if that makes sense, but that's all I can muster. I'm really loving this dark mode. Like, I don't know if I'm going to get over this anytime soon. It's so nice to be able to write and know where the picture ends so that I don't accidentally write on the picture, and then when I need to shrink stuff, it will also be easy. I don't know. If you don't know what I'm talking about, watch my earlier videos. Right, so as discussed, the bottom becomes cos squared x, again using the squares identity. I'm gonna do horrible thing and go sideways. So we have one term at the bottom, one term at the top, so we can cancel, and so we are just left with 1 minus sine x, which is indeed equal to the right hand side of the identity. Nice, nice, Aster. I don't know what Aster means. Doesn't it mean iron? Interesting. Anyway, so given the same expression, for what values of x in the interval 0 to 360 is this expression undefined? Okay, so we don't have any tans in the mix, so we don't have to make any considerations of where tan is undefined. So really the only thing we're concerned with is when this denominator is 0, because other than that, cos and sine are defined for any real number x. So really the only thing we care about is that this division can't be a division by 0. So it will be undefined. Let's write it in words. Oh, this is already an I. It will be undefined when 1 plus sine x, sine x is equal to 0. In other words, when sine x is equal to -1. And if we just quickly look at the interval from 0 to 360, right, this is our x, this is sine x. Oh, I'm on eraser. What was this with trousers? Okay, so then the curve will look like that, right? And this is where sine is -1. It happens over here, right? When x is equal to 270 degrees. So, i.e. when x, right, and that's because we're specifically looking at the interval from 0 to 360. If we're looking at a general solution, then it would be 270 plus or minus a period, right? So plus or minus, well, not plus or minus a period, plus or minus any number of periods. So 270 plus or minus, well, not plus or minus, plus k360, right? Because the k covers the plus or minus if k is an integer. Anyway, well, that really did become such a wrong ramble. All rambles are wrong. Right. So forward we go to the last part of the question. Write down the minimum value of the function defined by this guy, right? And this expression is the same as this expression. And of course, we don't know how to draw this. We don't know. But we did discover earlier that this is the same as 1 minus sine x. So really, in order to find the minimum value of this function, we just need to find the minimum value of this function. And we do know how to draw the graph of this guy, right? It would be, first of all, okay, maybe let's not make it so big. So y is sine x goes like this, wee wah wah, right? Has its minimum at -1, has its maximum at 1. So then, or maybe I should draw it very big so that I can layer them. Ooh, big. Right, so now, what? So y is equal to minus sine x would be the reflection in the x-axis, right? So that's going to go like this. So the minimum value doesn't change, it just changes where it happens. It's giving DNA what, right? So the minimum value is still -1, maximum is still 1. Right, and then lastly, the pièce de résistance. You know how you say that. If you know how to say it, please leave a pronunciation in the comments. So that is pretty much the same as minus sine x plus 1, i.e. How am I going to do this? Okay, I'm going to draw on top of the green one, right? The y is equal to minus sine x. And then I'm going we're going to move it 1 unit up. So now the minimum will no longer be -1, it will be at 0. That turned out quite chaotically. Let's let's see if we can move everything down. Oh my god. Okay, I guess we don't have to go all the way there. That's better. Makes me sleep at night. Right. Yes. So anyway, we've already got our answer, but okay, we're busy finessing here. So the minimum value of this function would then actually be 0, and the maximum would be moves from one unit up, goes up to 2. So we can now answer our question. Minimum value of y is 0. Okay. Memo, what do you have to say? I don't know why I keep singing on these videos, because every time I hear myself by mistake, I cringe so hard. I'm just like, yo, volume went from 0 to maximum so quickly. Nah. Okay, they offer a whole lot of approaches for solving the identity. So here's an interesting one that they do. So over here, the approach that I took was to multiply by the conjugate so that we could turn the denominator into a difference of squares, knowing that it would then, we could replace it then with cos squared x. But what they did as well as another approach is, ditch the conjugate, rewrite this as 1 minus sine squared x, and then you've got a difference of 2 squares where one of the factors is 1 plus sine x, so you could cancel it out with this guy, and the other factor is 1 minus sine x. So that is cool. I like it. Another approach that they took was to replace this sine squared x with 1 minus cos squared x already, and then there's some cancelling stuff that happens. That's also cool. In a nutshell, the world is your oyster. So, right. Next question. We do agree x is equal to 270. So even if you didn't know that this is like to do with one of the most special angles, I don't know if I'm abusing the phrase special angles, but like these weird ones, 90, 180, 270. So you could have done it the normal way, right? Which is to say, okay, we're trying to figure out which angle in this interval has a sine ratio of -1. So first let's get our ref angle, which will be inverse of sine of 1. And come on, Kalki, I know it's been a while, but jeez, man, get up! Right, which would give us 90. And then we know that, okay, the other angle, hey, how would you get the other angle? Oh, if it's negative, you know that it's either 180 plus or 360 minus. So whether you do 180, 180 plus 90, you'll get 270, or 360 minus 90 also give you 270. So definitely another approach you could take. Right, and then the last again, the minimum is 0. Great, that ends this ramble. Yeah, come back again.